Hello and welcome to another episode of TechHub.Training. Today we'll be going over the challenge COGS costing in Python. So let's jump right into it. Here we have our Jupyter notebook. We'll go ahead and run this first cell. The first part of the problem is actually just getting the data that we need. So we'll use the CSV file path sample underscore transactions.csv, and we'll use pd.readcsv. We also want to make sure to parse the dates column. You can use PD to date time after you read this in, but it's a lot easier to just, when you're reading it in, put into that function the parse dates equals, and then go ahead and put brackets with the name of the column that you want to be parsed in as a date. So when you go and look at the CSV, it'll have date as the header in that column. And then we'll print it, kind of see what we're working with here. It looks like the information that we need is all there. The next thing we want to do is sort the data frame by the date column from oldest to newest. So we just go ahead and do sort values, and we don't need to worry about doing it from oldest to newest. And the reason, from newest to oldest, the reason why is it'll automatically put that in. If it were the other way around and we wanted the oldest dates at the top, we would need to put in an argument for ascending equals true or ascending equals false. But because it's automatically going to put the new ones at the top, we don't need to worry about doing that. So we'll go ahead and reset the index, just df.reset index. We'll say drop equals true. That's going to get rid of any old index. And this will create the new index and leave it in place. So we're dropping an old one and putting in a new one here. And then we'll print it to see what we have going on. Looks wonderful. Next up is just going to be our Boolean column that we're going to create called isSale, and that's going to just equal and here we will call the column name of the data frame, and then double equals indicates a Boolean, so it'll say yes, or it'll say true or false in the column after we do that. And then we'll make our revenue column, which is going to be equal to our quantity times our price per unit. And we want to make sure to multiply it by the Boolean column that we just created, because if the Boolean column returns a false value, i.e. it's a purchase, not a sale, this will be multiplied by 0, which will set revenue equal to 0, which is perfect because when we're purchasing anything, we don't actually have any revenue to recognize. But if it is a sale, this will be a 1, so it'll just be multiplying this by 1. So that'll work perfectly for our purposes. We'll go ahead and run that as well. Wonderful. Oh, and we need to sort it. We need to run that cell first. Perfect. Okay, and that looks great. So the next thing we're going to want to do is we want to create a couple different columns here. We want running quantity, running total cost, and COGS. So you don't necessarily have to set variables to keep track of running quantity and running cost. I do, just because it makes things a little bit easier for me to keep track of. But we do that, and then you can use iteros, and we'll have an example of iteros later on in this video. But for this one, I chose to do df.index. Iteros is generally not the preferred choice. It uses a lot of processing power. So if you can do it without using iteros, that's ideal. In our case, it won't really hurt us to use iteros because we only have a few rows. We don't have more than 100, which 100 wouldn't even be an issue. It's mainly a processing power issue when you have a really, really large data frame. Because this is just a practice problem, we won't have a super large data frame, and so iteros will work just fine. But that's something to keep in mind when you're designing these processes for larger data frames. So we make a for loop, and then we say for n in df.index, right? N will correspond to the row base, essentially. It'll correspond to the index, but it'll correspond to the row for our purposes. So say, okay, great. Now, if and we'll say df.log, and we'll say n, so indicating that specific row. So we're going through each row, and then we'll say, okay, the column type in that row, if that happens to be purchase, here's what we're going to do, right? And we'll just, we'll increase the running quantity by the quantity amount in that row, and we'll increase the cost by the price per unit times the quantity in that row. Perfect. And then we'll say our running quantity is equal to that running quantity number that we're keeping track of, and running cost down here. And again, you don't need to necessarily create these variables. You could just simplify this into a couple lines of code. I like to do it this way. It's a little bit less efficient, but it helps me keep track of where everything's coming from. And then we'll set COGS equal to 0 because, again, it's a purchase row. So we're not having COGS when we're doing purchases. That's something that happens when we have sales. Now, when we have sales, we want to do COGS first because we're going to reduce running quantity and running cost by the amount of the sale. and by the amount of COGS. So we want to set COGS first. So our column COGS in that row is always going to be equal to our average or our running cost divided by running quantity. That'll get our average cost of 1 unit of the product times our quantity in that row, the quantity being sold. And that will get our COGS. Perfect. There's our cost of goods sold. And then we're going to reduce running quantity by the quantity in that row, the quantity being sold. And we're going to reduce our running cost by the COGS, the cost of goods sold in that row, which is perfect because we just did it up here. So that's the order that you want to do that in. Next, we're going to do our running quantity and our running costs, which will just equal those after we'll have reduced them up here. So that's perfect. So we'll go ahead and run that. And perfect. It's looking great. COGS is looking good. There's our running total cost as we keep going down. And there's our running quantity. And the reason why the running total cost is going out to a few decimal places, we didn't set it to only go out to a few decimal places. So that's fine for right now. Because we're dealing with dollars, we know it's really only 66 cents and things like that. But the reason why it's going out that far is because we're subtracting COGS, and COGS is a function of the running total cost divided by the running quantity, which doesn't always equal out to a round number. So when we're subtracting COGS from running total cost, that's why it's turning into a larger decimal. Okay, the next thing we want to do is look at our profits. So profit is easy. It's just going to be our revenue minus our COGS, which is perfect since we have those columns now. Profit percentage is going to be our profit divided by revenue. Again, really easy. Here's an example of iteros for you. So here we took our running profit and we made that equal to 0, and we created an empty list for total profit. Those are basically the same thing, but we wanted to name two different variables, right? So then we'll do for I row in df.iteros, and we'll say our running profit we'll add to it our profit, right? From that specific row. Pretty easy. And then to the list, we're going to append that running profit, right? Pretty easy. And this is really easy because for our profit in our rows that are purchases, that's just going to be an NA value because you can't divide by 0. And they don't have any profit associated with purchases. So perfect. Once we've done that really quick basic iteros, we just say df running profit equals total profit. That's just going to make a new column, and that column is going to be equal to a list. It would throw an error if our list wasn't the same length as our data frame. So we have 69 rows in the data frame, and we have 69 entries in the total profit because we did it by iterating through the rows. So there's that for you. That's an example of iteros. And then we want to filter just to find sales because we kind of want to see our profit through the year. That's what the client wants to see. So we're going to say df, and then we're going to call df in here again because we're going to be calling the column. So when we call this column type, we need to call the whole data frame. So we say the data frame, the column type in the data frame equals sale. And we want to take those rows of the data frame. So that's what that first one is. It's saying take the data frame where the rows of the data frame of column type equals sale. And then we have the filtered data frame right there. Perfect. Here's going to be our matplotlib question. So we're going to first, get some subplots here because we're going to need 2 axes, right? We're going to need 2 y-axes. So we'll say color tab red, pretty basic color. You can choose to do whatever color you like, but then we'll say axis 1 dot set x label dot set y label, pretty basic stuff. We're setting the labels here, and then we're going to do the actual plot of the first y-axis, right? Of the first axis essentially. You'll see in just a second. They'll share an x-axis, but we're just going to make that x-axis the same. So here in the first one, the x-axis is going to be our filtered data frame and the column date. That's going to be the values for our x-axis. And then we'll do, for the y-axis, we'll do running profit. Easy. And then we'll put in some tick parameters, et cetera, et cetera. The second axis, again, we're going to do a twin x. So what that does is it doubles the last axis, essentially. And then we'll have, we'll set the color to blue just so you can see the different ones. But then we'll set the y labels. And we don't need to set the x labels again because it just twinned that x-axis, right? And so then we're going to plot it against the x-axis will be date. And the reason why we need to specify that here is because it's plotting the data against other data right now. So if we chose something different here in this x-axis right here, that wouldn't make our graph look different down here. It would still have the dates down here, but it would make it look different because even though Like, for example, if we decided to plot it against quantity or something totally unrelated, it wouldn't change the dates down here, but it would change the way this blue line looks because it's being plotted against quantity instead of date, but we wouldn't be able to see that because this would only show dates. So that's why we need to make sure that the x-axis is equal to date when we're doing the dot plot right here. And the same thing for the y-axis, we're going to do profit percent instead of running profit. Perfect, easy. And then we'll do tick parameters. This is going to be the line style as well. Again, most of these are just like design options, so you don't need to worry a ton about them. Next, we'll want to put on a title. Again, you can choose whatever title you want, just as long as it's descriptive and makes sense. This is, again, just another design setting that's not super relevant to the project. And we do plt.show to show that plot. And there you go. So that is the answer to the COGS costing problem. Let us know in the comments if you have any questions. Thanks.